The next question says we should find the bearing of x from z to the nearest degree. Moving from the north direction, we move to east is 90 degrees, to south 180 degrees, to west 270 degrees, and then if we move to the north direction, we can see that this angle here is alternate to this angle. So back to the y coordinate, we can see that we have here to be 30 degrees, we have here to be 30 degrees, we have here to be 120 degrees to give us 150 degrees. And we know that from the north to the east is 90 degrees, so we have 90 degrees out of 150 degrees. So we have 150 degrees minus 90 degrees will give us 60 degrees. So we have here to be 60 degrees, and this angle is alternate to this angle. So we have here to be 60 degrees. Since we know that from this point to this point is 270 degrees, we simply add 270 degrees plus 60 degrees, we have 330 degrees. Now to find the bearing of x from z to the nearest degree, we simply add 330 degrees plus theta. So therefore, using the sine rule, we know to be b over sine b is equal to small c over sine c. So the same for this part of the question, we change the parameter. We know our b to be y, so we have small y over sine big Y is equal to small z over sine z. So we found our y in the previous question to be 114 kilometer over sine. We know our big Y to be 120 degrees is equal to our z from our question is 50 kilometers. So we have here to be 50 kilometers over our sine z is theta. So our sine z is sine theta. So if we cross multiply, we have 50 kilometer sine 120 degrees is equal to 114 kilometer sine theta. So since we are looking for theta, we have sine theta to be, we have 50 kilometer multiplied by sine 120 degrees over, we divide both sides by 114. So we have here to be 114 kilometer. So have our sine theta to be equal to, if we use our calculator, we have 50 kilometer multiplied by 0.8660, that's sine 120 degrees over 114. So we have our sine theta to be equal to 43.301 over 114. So have sine theta to be equal to 0.3812. If you use a calculator, that's what you get. So we have theta to be equal to the sine inverse of 0.3812. So we have our theta to be equal to 22.411 degrees. So now we've just gotten our theta to be 22.411 degrees. Now remember, we're asked to find the bearing of x from Z, which is equal to 330 plus theta. So now we have our theta to be 22.411 degrees. So simply add it to 330 degrees plus 22.411 degrees. So we have 352.411 degrees. So we're asked to leave our answer to the nearest degree. So this is equal to 352 degrees to the nearest degree. Now this is our answer, and we are not done yet. We have found the distance between x and z. We found the bearing of x from z to the nearest degree. Now lastly, we have to find how far east of y is z. So now we know this place to be, here to be 352 degrees. We have to find how far east of y is z. So we are moving in this direction. So we are talking about east of y, moving eastward from y to z. So we are moving in this direction to z. This forms a right angle triangle. Okay. So using SOHCAHTOA rule, we know that this is a right angle triangle where this side is our hypotenuse, this is our opposite, and here is our adjacent. So we're asked to find our adjacent. So we're looking for adjacent. We're going to use CAH. So we know our CAH to be adjacent over hypotenuse, which is equal to cos 60 degrees. We got 60 degrees since this angle here is 60 degrees, so we are using cos 60 degrees. So we have our adjacent to be r, in which we are looking for the distance we are looking for, our hypotenuse to be 80 kilometers, equal to cos 60 degrees. So we have our r to be equal to 80 cos 60 degrees. So our r is equal to 80 times 0.5. So r is equal to 40 kilometers. So therefore, our answer r is equal to 40 kilometers. Now we found out the value for r to be 40 kilometers. So our comment, z is 40 kilometers due east of y. Thank you for watching this video. On our next video, we'll solve question 2 on bearing and distance.